Hello everyone, this is a video on inverse function. But before I show you and talk about inverse function, I want to talk about what is a function. A definition of a function, it's a graph where for every x value there is one and only one y value. So I'm going to draw some few graphs here and show you which ones are functions, which ones are not. Right. When you look at the first one, the definition says it has one, and for every x value there's one y value. So when you draw a line here, let's say x is minus 2. Do you see you only have one y value there? When you go there, you have one y value. You have one y value, we have one y value. So when you draw a vertical line, it only touches the graph once. If that happens, that shape or that graph is a function. Now let's look at this one. When my x, let's say it's minus 1, my y, it's either 4 and minus 4. So it has two y values. This is not a function. Also, when we're talking about the vertical line test, at any point it touches twice. So that is not a function. This one also, it's not a function. So in that one also, it's not a function. So it is important to remember the definition. Before you do the inverse, you must know what a function is. Let's start with our lesson. The first thing, how do we find our inverse function? When you have an equation like this one, you replace f at x with y. And then after that, you swap x and y. What they mean, where there is x, you write y. And then you solve for y in terms of x. This means in your answer, you still have x. And then replace y with f negative 1x like this. These things mean inverse of a function if the inverse is a function. Okay. This first question says we must draw f at x. So we'll start by drawing f at x. Now, this is a parabola. It's a quadratic function. When a quadratic function doesn't have an a or a b, it means the turning point is the y-intercept. And then you can't find the turning point because you'll get 0, 0. So you have to choose your points, any point. I'm gonna choose f at 2, 1/2, 2 squared. And then I'm gonna do f at minus 2 as well. 1/2 minus 2 squared. Okay. 1/2 times 4 okay, it's 2, and this, because it's squared, is also going to be 2. Okay, so I'm going to draw my function here. My function, it's minus 2, 2, and my coordinate, this coordinate is minus 2 and 2, and that coordinate is 2 and 2. Then my graph will go like this. Go there, pass there, go there, like that. So this is how you draw the function. Right, the next question says we must find the inverse of the function. Let's look at the step. They say we must swap around. We must start by writing, instead of f at x, you write y is equals to 1/2 x squared. After that, you swap around. Where there is x, you write y. Where there's x is equals to 1/2. Where there is y, Right, so what do I need to do? I need to get rid of that. I'm going to multiply by 2 both sides. Then I have 2x is equals to y squared. Then I square both sides. Then I have my y is equals to, the square root is always plus minus square root of 2x. This is my inverse. Okay, the equation is y is equals to plus minus 2x. Okay, that's question C. Find the domain of the inverse. Always when they ask you the domain and the range of the inverse, start by writing with a pencil somewhere the domain and the range of the original one. Here, they've asked us the domain. So it means is the range. You remember, where there is x, you put y. So it means your domain becomes your range. Your range becomes your domain. So I need to write the original one. For the original one, the domain is x. X is an element of all real numbers. That's my domain. And my range, because it's a hyperbola, it's y is greater or equal to the x-coordinate of the turning point, which is 0 in this question. This is my domain, this is my range for this graph. Now for the inverse, that's my number C. You see, that I wrote somewhere where I'm going to rub. Don't write it in your question paper because they'll mark you wrong. They'll think you don't understand what you're doing because you're giving the wrong answer. This is the domain and the range of the original graph, not the inverse. Here, they're asking you for the inverse. When you're calculating for the inverse, what did they want? Is the domain of the inverse. So I go to the range of the original. That's my answer. Then it's x is greater or equal to 0. What do I do when I get there? I swap around. Where there is y, I put x. That's all. I want to show you how to draw the inverse. In a question paper, when they say draw the inverse, you saw the equation there is square root of, how are we going to get the turning point of that? So when you are asked to draw the inverse, draw the original function first and then swap the coordinates around. But the example that I used had too many 2's. So I think it will miss the point. So I'm going to use different coordinates now. I'm going to use, I'm going to change to when I have, my x is 4. So I'm going to have 4 squared and my y will be 8. If my x is minus 4, I'm going to have 1 over 2 minus 4 squared. My y is still going to be 8. So let me draw the function. My turning point is still going to be 0 and 0 because I don't have A and B. No, B and C. And then here is minus 4. Here is 4. And there I have an 8. This coordinate is 4 and 8. And that coordinate there is minus 4 and 8. So I'm going to draw my function like that. Don't forget to show the arrows. Right, now I'm going to draw the inverse. When you draw the inverse, you just swap the coordinates around. 0 and 0 will still be 0 and 0. It will be there. 4 and 8. It will be 8 and 4. So my graph is a little bit short here. It will be 8 and 4. And then minus 4 and 8. I'm going to swap the coordinates around. It will be 8 and minus 4. So it will be there. Then my graph is going to go like that. No, man. Not there. 0 and 0. My turning point is 0 and 0. Not there. It's gonna go to there. Right, yes. This is my inverse. I wanted to draw my inverse in red, I forgot. So that's my inverse. Now look at my inverse. Is it a function? No, it's not. Because for example, that coordinate that we use 8, you had two values of y. We had y was 4 and y was -4. So this is not a function. So you can restrict it to make it a function. When you look at this original one, if I can only take x greater or equal to 0, meaning that I'm taking only the positive part, I rub this one out. In my inverse, that won't be there. Then my graph will be a function. Or I can take the negative side. X is less or equal to 0. So in a question paper, when they ask you how are you going to restrict it, they mean how are you going to make it to be a function? By either taking one side where x is positive or where x is negative. Okay, let's look at the exponential graph. Okay, now we are given an exponential graph. We are asked to draw the graph. Right, you need to watch our video on exponential functions. The first thing that you need to find out is the shape of the graph, because it's positive, and here it's positive, not a function, a whole number, and here it's positive. Your graph will look like that. But where would it cut? When you don't have a Q, your graph always cuts at 0 and 1. Your y-axis is every time 0 and 1. So you don't need to calculate it. You just need, it's something that you learn, that if you don't have a Q, your graph will cut at 0 and 1. Okay, then the next thing, you need another point. So you need to know your graphs to know in which quadrant are you going to calculate. Your graph is going to come like that because it's a whole number and it's positive. So it's going to be above the asymptote. What is my asymptote? My asymptote is the line y is equals to 0. Which line is that? Is the x-axis, is this line. So my graph would go towards this line. Okay? Now, I need to find another point. The point that I'm going to find is in this quadrant. So I know that must I go that side or must I go up? In which direction to go? Let's find the other point. Okay. I choose my x to be 1. So my y will be 3. So my other point is 1 and 3. So that's my 1 and it's 1, 2, my 3 there. So that's my other point. What's the point? It's 1 and 3. Okay, so I can draw my graph. Come like that, pass there, go there, like that. So we've done the first part. We've drawn the graph. Now let's find the inverse. Okay, let's do number 2. We find the inverse. When you find the inverse, so you must replace f at x with y. In this case, it's y, it's g of x. So we have y is equals to 3x. Then we swap them around. Get x is equals to 3y. And then now, your y is an exponent. I want to write it in the form y is equals to. So you use a log. You need to remember that a log is an exponent. So my exponent y is equals to a log. Log, what is my base? My base is 3. Which number is left? X. This is the equation. Then I have to do the last part. Replace g x log base 3 log x base 3. This is how you write the inverse. Okay, now we're going to draw the inverse function. You don't worry about the logs, about what, all of that. You just take the original functions, you swap them around. 0, 1. So it means I have 1 and 0. My x is 1. My y is 0. My pen doesn't look nice. So that coordinate is this one. Okay? Then I have another coordinate. 1 and 3. So it means it will be, my y will be 3. Let me extend my line. My y, my x will be 3 because we just swap them around. My x will be 3, this is 3, and my y will be 1. So the other coordinate will be there. Now, another thing that you need to remember, you remember the asymptote was y is equals to 0. Now the asymptote is x is equals to 0, which is the x-axis. So your graph will come going like that, go there, go towards this, and don't touch the y-axis. So this is how you draw the inverse. Also, when you get inverse, sometimes they'll ask you with a turning point. They'll say, what is the turning point of the inverse? Don't try to calculate. When it say inverse, just swap x and y around. That's all you do with inverses. This is one of the easiest section. Love inverses. Thank you for watching. Please subscribe. This is the end of the lesson.